start with module 3?
Yes, Doctor.
Okay, thank you. Okay, bismillahirrahmanirrahim. Kita start dengan our module 3. Okay, there is a variety objective that you need to achieve throughout your module 3. After you finish with module 3, you need to like understand the interaction between computer hardware, operating system, and also your application program. So what is the example on application program? So now the things that I use is PowerPoint, right? PPT, PowerPoint, which is Microsoft Office, of course. So it is similar to application program. There is a lot application program in your computer, and one of it is a PowerPoint. Next is operating system. Currently, I am using iOS. My operating system is Montera, I guess so, because I already updated my system. So that is operating system. For those who are using Windows, so Windows is your operating system. And computer hardware, of course, your computer, your laptop, your notebooks, and etc. So here is you going to understand interaction between your computer and then your iOS or maybe your Windows, and also your operation, which is your Microsoft. And then what you need to achieve, which is you can apply test theory information give in computer architecture and your operating system. Lastly, you can write a basic assembly language and execute the program. Last time is you still remember we try play around with our Visual Studio, which is we just copy paste the assembly language given. So by finish the module 3, we can proceed with our lab 1, which is very simple things because you know already the assembly language. So what we're going to look into our module 3, it is basic element and the assembly language, because we need to know the basic thing before we going to go for master, right? Example like editing and subsetting integer. That's why you can see we will always terjumpa, we're going to meet integer. What is integer? It is number, right? It is number. So that's why I want you to strong your basic on numbering system. I already provided the notes, which is from the integer logic, especially for your numbering system, and share also the video for our extra class last time. So please make sure you understand the very basic of numbering system, because in our COA also, although it is about assembly language, but normally we're going to meet also in our numbering. Although you understand how to write a coding, but when you don't know about numbering system also, you cannot write a correct number. Let's say there is a hexadecimal. If you don't know about hexadecimal, you can write instruction, you can write the register command and etc. But the value will be wrong if you don't know the octal, the hexadecimal, the decimal, the binary, right? Next, you're going to know how to define your data, symbolic constant. So all of these we will cover in our module 3. So why you need to learn assembly language? I thought this one I already informed all of you, because assembly language is the basic in programming. Before you can go for C programming, before you can go for HPPC, before you can go for Python and etc. So you need to know the assembly language first. By knowing this assembly language, the architecture, how you're going to write, so you have a basic understand on to write a programming. So when you have this basic, it's easier for you to move to any programming language. You can go for Python, you can go for Java, you can go for C++, etc. So that's all on from the basic. And this one is native machines, and like you can know after this like passive machines language, native, and etc. Machine language is numeric language. So you can see this. That's why still number is important. Although machine language is just to know about 101010, I already mentioned you. Still, if you don't know like about binary, you don't know how to convert to octal, you don't know how to convert to hexadecimal, and it also will be difficult to you. So that's why number is important. And how it's going to process in your CPU, we will cover all. Assembly language provide direct access to computer hardware, which is it require you to understand about your computer architecture and also your operating system. Each assembly language instruct correspond to a single machine language instruction. So let's we see basically what we're going to cover in our first subtopic, which is basic elements of our assembly language. So what is basic element? Basic things that you're going to apply. Basic yang akan you gunakan into your instruction, into your coding, and the assembly language. So if you look this list, if you look into this list, you can see also there is number there. Integer constant, real number constant, character and string constant. So still there is a number. That's why I hope that you can understand first the numbering. So without further delay, let's move to the very basic integer constant. So when you heard about integer, of course, it is related to your numbering. But what is constant? So an integer constant or an integer literal, it also can call as an integer literal, is made up of an optional leading sign. So you need to have sign. If let's say you have 2, 7, so in representing as an integer constant, you need to also put the sign in front. If it is positive, because normally positive we will like ignore, because we know, okay, 27 is positive number. But in terms of integer constant, you need to put whether it is a positive or a negative. And this 27 is our digit. Is our digit. And you need to know also the basic number. Basic number, base 10, base 2, base 3, 8, and etc. So last time in your extra class, if you still remember, I already mentioned that, oh, you need to know also about hexadecimal. Because normally in our number, we're going to put like 2, 6, base 4, let's say. Or maybe octal, okay? Hexadecimal is base 16. 2A. 2A is our hexadecimal number, and normally we're going to put like this 16. And in our extra class, I already mentioned that you cannot put these 16 into your programming, into your assembly language. Instead, by putting that, you're going to put right H. H mean hexadecimal. And there is several way, which is how you're going to write your numbering. Later on, we will cover that. But for first, under integer constant, you need to write the positive or either a negative. The digits, the value of your magnitude, and your radix. You can see here is listed there about your radix, whether it can be a uppercase or a lowercase. You can see hexadecimal represent as H. R is an encoded real, which is you put after the numbers, after the digits. Octal, it can be as a Q or O, not a zero, okay? It is O over here. Decimal, you will put D. Binary, you will put B. T is also decimal but alternate. You can see it will be like putting as alternate. And Y also binary, which is similar to binary, which is alternate. So you can memorize. You need to memorize all of this, because later on when you write a code, you need to apply into your programming. So here there is an example how you're going to represent your numbering in terms of integer constant. If no radix is given, the integer constant will be assumed to be decimal, because I already mentioned that our daily numbering system is decimal, which is base 10. So we will assume that our normal like 109, this is, we know this number only, but the basic now we know it is decimal. So that's why we are rarely put base here, because we already know, okay, this is decimal, our daily numbering system. So we didn't put the radix. But if different base we need to put, because we don't know basically what we can assume. So you need to remember, if there is no radix, which is like this, there is no radix that mentioned here, so you need to assume it to be decimal. You can see also this one is 26 decimal. You can represent this or here, which is the value similar to each other. And this one, of course, this is binary. This is your Q. Q is what? Q is octal. You can see here, refer it back. Octal can be Q or also a zero, not zero, O. So here is O, which is octal. Now it's hexadecimal. And there is another one more thing. First is this one, which is if there is no radix, it's assumed to be decimal. And one more thing, if you play around with hexadecimal constant, you need to remember this thing. If you still remember, under our hexadecimal numbering, we have A until F. Why we have A until F? To represent 10 until 15. Okay, that is one thing that you need to know. Okay, now if let's say your number in your hexadecimal is like B2, B2 base 16. So you know that this is hexadecimal and B will be 11. and 2 will be 2, of course. Going to multiply with your 16, the power of 1, 16, the power of 0. So this one will be multiplied with 1. This one will multiply with 16. So you add up together, then you will get the total of decimal number. But this is how you're going to convert hexadecimal to decimal. But in the representation, you can have like B2, base 16. But in your assembly language, when you have a letter, in front, so you need to put 0. Sebab you tak nak kelirukan you punya coding or programming. So you need to add 0 to avoid any confusion for your programming. Because if you put like B or A or C or F, they will like assume, okay, it will be like a character, it will be like sentences. So to put it and to make your machines know this is number, so you need to put 0 in front. So this is the rules that you need to know under integer constant. Okay, next. For real number constant, okay, just now you know about number constant. Now you have a real number constant. What is the difference? So under a real number constant, it's much more complicated because you have here a sign which is either it is a positive or negative. You have integer, and then after that you have also radix points there, and then any value after your radix point, after your point here, and there is integer, and sometimes you will also having the exponent. So this is the format for you to write a real number constant. The example, if you can see here, the example, which is the valid real number constant, you can have 2 point something, and then you can also have the positive in front, 3 point something. It also has to be as a real number constant, negative, blah blah blah, and then you have another exponent. Without exponent also it can call as a real number constant. So this is all the example valid view for you to represent your real number constant in your assembly language. Next, on character or string constant. So that's why you can see here, you have A, you have D, whatever letter you have from A to Z, you can call it as a character and string constant. That's why when you want to state or inform to your machines, this is number. When you having a hexadecimal, you need to make sure the leading or the first value of your number, if it is a letter, you need to add 0 in front, okay? So you need to add 0 in front, because 0 won't affect your magnitude and also your value. That's why you need to add 0, just to make sure that your computer will not confuse, because there is a character and string constant which is going to put as a letter. A character constant is a single character which is you enclose it using a single or double quotes. You can see here. So you can have either one, whether you want to apply a single or you want to apply using a double quote. It depends. So it is under character character constant. And it is normally under ASCII character. ASCII character also I already provide you in the notes. Please make sure you refer it back. And a total is 1 byte. Please make sure you know what is 1 byte. And we also have already take a look into 1 bit, 1 nibbles, 1 byte, and another one is words. So it will be also asked in your test 1 because that things we already cover in our digital logic and also in your module 2 on the COA subject. A string constant is a sequence of character, including the space, but you still need to use a single or a double quote. Why you need to use this? Because your instruction kan, instruction you punya dalam you punya programming, dalam you punya coding, normally you also will like putting character which is like instruction move to whatever da 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 da. So computer don't know what is the type of this. So if you normal typing without any a single or double quotes means that it is instruction for a machines. So if under a number, there is a several thing how you going to put. And if you just want to put a character, just maybe you said, okay, you nak print this good night, Gracie. Good night, Gracie. You want to print this. You want to give a output like this. So your computer need to know, okay, this is something that mentioned under character or a string. So you need to put single or a double quotes. Just to differentiate between your normal programming, your normal codes, and also character and also string constant. So embedded codes are permitted when used in the manner shown as a following. So this is a code that you can use. You can see if you want to print every single things here, you can put another one inside. It is called as embedded code. And you can see inside your double code here, you can see there is another single quote. See, inside a single quote, you can also have another double quote just to apply the embedded code. You want to put something inside also can. So that is about your number constant and then real number constant, and the third one is your character and also your string. Now you need to have, there is a reserve word you cannot use. Okay, later you will like learn about identifier. Identifier is for you to like, maybe okay, you want to create a group, you nak buat group for your sport day. It will be like normally you say, okay, group A ataupun we don't want to call it as A, we call it as yellow group. Kalau sukan kan kita ada yellow group, ada green groups and so on. So all of this we going to apply in identifier. But of course, when we put the names, that is for numbers, nama sukan. It's easy for us because it is like a color. But there is a certain things that you want to create a group name. So when you want to create a group name, you need to avoid to use a reserve word. If you want to use like a group name, but maybe you put like a move or add or mults, which is multiplication, or also include. Because sometimes kita bagi nama group ni tak kisah apa nama group kan. That is the thing, because kita yang mencipta group tu. But you cannot use reserve word, especially cannot be used for the identifier. That's why before you learn identifier, I inform first identifier is something that you are the one that rename. So you cannot use this reserve word to identifier. So what is reserve word? Reserve word can be instruction mnemonic. Move, maksudnya you akan movekan you punya value pergi mana ke mana. Ini adalah instruction dalam you punya programming later on. You akan belajar this one. And then you also have ADD. Programmer ni normally adalah seorang yang malas, which is they are too lazy to write a long addition. This one multiplication, because they want it to be fast. That's why they was always thinking, okay, apa short form dia, apa short form dia. Then they use this short form to represent as instruction. But you need to know, okay, this is the short form for addition. This is the short form for multiplication. You give this short form as instruction to your machine. So all the instruction mnemonic, this one is just example. There is a lot others, of course. So this instruction you cannot use to your identifier. Directive, which is include. Any directive, you include what, include what, which is you cannot use for your identifier also. It is a reserve word. Type attributes, which is like a byte, words, bits, nibbles, apa lagi yang you ada which is under your type attributes, you cannot use also to your identifier. And operation, also it is a reserve word. You ada tambah, tolak, darab, bahagi, whatever you have, then you cannot also put and apply into your identifier. And lastly, your predefined symbol, also you cannot use for your identifier. That is all reserve word that you need to know. Okay, so next we have identifier. Identifier saya dah bagi tahu tadi, which is the name that you, the one which is a programmer, choose. You are the one that choose. You nak beri nama dia sebagai yellow ke, you nak bagi nama dia sebagai green ke, you are the one that identifykan dia, because you yang akan tahu you nak identifykan dia macam mana. So it is called as identifier. Programmer choose the name. It might identify apa yang you akan identify, which one, which is your variable, a constant, a produce, or procedure, or a code label. So dalam programming you, there is several other things that you need to define as a group, as a whatever things. So it is under identifier. Let's say you nak identifykan you punya constant. So you nak cakap at the beginning you nak inform which is maybe you ada, okay, apa I nak guna saya. Okay, let's say saya, okay. Saya is equal to 171. Let's say you identifykan this. Okay, so you know, okay, saya, whenever you call back saya, then your computer will know, okay, saya is 171. So you identify it already at the top of your assembly language on your programming. Then later in your programming, there is a long programming, of course. Then whenever you say saya, then your computer know, okay, saya is, then refer back to your upper side at your programming, or saya is 171, they say. So that is things that you might identify. Someone trying to join us. Oh, okay. Okay, I'm continue back. Okay, you can see it may contain of 1 until 247 character including digit. Apa character tu? You're going to have A until Z, which is capital letter. You boleh ada juga A until Z small letter. You boleh ada number 1 sampai 9, 1 sampai whatever number you have. Of course, we're going to calculate only 0 until 9. And then you can also have symbols, which is, it is not case sensitive. That's why you ada capital letter, you ada small letter, you ada symbols. And subsequent character may also be a digit. Dalam tu you akan ada juga digit. Identifier cannot be the same as assembly reserved word, which is the things that we just cover. Kita tak boleh ambil whatever reserved word to be as identifier. So what is the example? The symbol is used, you can see under your extensively assembler as a prefix of predefined symbol. So avoid using as identifier. Make this one normally, because you will assume it to be a predefined symbol. So avoid untuk guna this symbol, because normally you akan guna dia sebagai predefined. So kalau you nak letak nama, whatever nama, tak payahlah you letak this symbol in your identifier, because it might confuse your machines. Make identifier name descriptive and easy to understand. Senang, yang nama yang senang, walaupun is apa orang kata tak tahulah nama bombastic names, which is you want to be as your identifier, but you need to avoid like very hard to understand, too not descriptive, and then you put like very many symbols also, it might confuse your machine. So pick just an easy words for identifier. You can see there is example that you can use for your identifier. You can have a symbol, but please avoid, you need to avoid a predefined symbol. And you can see also you have a small letter, capital letter as a identifier. That is on your identifier. Next, what else that needs to be as a basic for your assembly language, which is you need to know on directive. What is directive? So directive, it can be a command embedded in source code that is recognized and act upon the assembler. So you need to have the directive. It is not execute at the runtime, can define variables, macros, and procedure. Not sensitive case. It also similar to your where is it? Okay. It also similar to your Directive here. Mana saya punya? It also similar to identifier, which is it is not case sensitive. Similar also with your directive. It can be recognized as dot data, sama juga with your dot data capital letter. So it is not case sensitive. And different assembler have different directive. Kalau saya buat directive saya sendiri, it's also going to be different with another program. So example, okay, dalam satu line instruction. Siapa lagi nak join? Sekejap I already click the auto admit, but somehow I need to open the Google Meet first, then it's auto. If not, it's like hanging there. Okay, here you can see example if you have this single line. So this is your example of your assembly code that you can use later on. Where is directive? Where is instruction? So instruction something that you instruct to your computer. Of course, here at this part, there is no this one. This is your directive. Which is it tell you the assembler to reserve a space of the program. Okay, double word. Berapa besar double word that you have? So normally you have one nibbles equal to 4 bits. Nibbles equal to 4 bits. 1 byte you have equal to 8 bits. One word you have 16 bits. So double word you're going to have 32 bits. So that thing also onto representation you need to know, because that will be knowing how many space that you have. Let's say it's just mentioned by, so you know, okay, it is only this 4 space for you to put this 26, because this one is decimal. There is no mention about any radic. We need to assume it as a decimal. So this decimal number you're going to put into your we can set that as header inside the space that available in our register, and it will be depend on the instruction whether you need to put on hexadecimal number or maybe in the binary. So you need to know there is only 4 bits for one nibble. If it mentions about 1 byte, so you have that space. So if it is only like 26, example for this, we just represent it as a decimal. So you're going to have like 0, 0, 0, 0, 0, 0 for another 6. So when you have another my var words, let's say 27. So another example. So you need to continue at this side. You cannot like put 27 because our first instruction already covered it. So next will be starting here. That's why you need to know how many bits here. Because if you don't know, then your answer will be wrong for placing the value. Here, you have move EAX MAVA. Means that the things that you already put into your MAVA, you're going to store it into your register. It instruct you. Then it said move is as an instruction, which is it's going to execute at runtime. Copy the constant of my var. See, copy Whatever in my var, you're going to put into your EAX register. So this is example. And it's only execute when you execute at the runtime. Before that, there is nothing in front in your EAX register. It will update when you execute, which is last time we use the what Visual Studio. We noticed that if we do step by step, then it will run this one, and then after that another one, so it execute at runtime only. Okay, 7, we have instruction. An instruction is an executable statement when a program is assembled. So this is instruction. You can give any instruction to your computer when you like currently I'm clicking at my escape button. So this is also can be called as instruction. When I click here, this is also instruction in terms of we convert it from clicking to instruction. We write already. If I click, yeah, if I click at this button inside our programming, when I click here, it will full screen. So that is instruction. Although you can't see basically the programming, you know already that you give instruction to your computer. Instructions are translated by assembler into machine language bytes, which are loaded and executed by your CPU at runtime. So there will be a separate 4 basic part under instruction. First, on label, it is optional. Sometimes you can have inside your coding. Sometimes you can't to do and write it also can. Second, you're going to have instruction mnemonics, which is it is a must. Wajib perlu ada instruction tu, which is like a move, add, sub, multiply. So that is instruction. Kalau you tak ada instruction, that's instruction mnemonics, which is the move and then adding. So you cannot know that you instruct the machine, right? So this is a must. Operation usually also sometimes required because you need to know what is operands that are used. And lastly, a command is optional. Normally comment is important for us who beginner, I guess so, which is because after this, if we want to check back our programming, then we know, oh, this part I did like this, this part I did like that. So you better for you to write a comment into your assembler, into your instruction, because it won't affect your programming. It is just for you. A comment is just a for you, or maybe whenever you like, okay, you already move to another group and the current project is going to hand off to another person. So what the person need to do is to read a comment. Okay, then he will learn. Okay, he know, okay, this is basically for this one, this is basically for this one. So it might easier the programmer. Under a label, you can see here, a label is an identifier that it as a place marker for instruction and also data. So how you going to label? Follow identifier rule. So data level have identifier identify the location of variables. And for the code label, so you can see you have 2 things for label: data label and code label. For a code label, use as target of jumping or looping. So this is example for you for code level. If you notice sometime we have a loop in our program. So it is a code level. We're going to have a loop instruction, which is target, move, and then you jump back to your target. It's already mentioned there. JMP means that jump, go back to your target there. So it will be loop inside. So instruction that end with a colon character. You can see here. You mentioned, okay, this is target and there is a semicolon, colon character, and you're going to loop inside here. So example, jump instruction, transfer control to label target, creating a loop. While for data label, you just instruct one time, mentions that, okay, count, dekat dalam count ni, dekat dalam count, you're going to put 100 with the space of the words, which is 32 bits. So you just definekan data label you ni, count ni, as a 100. So then you're going to have count. Inside your count storage, it will be having 32 bits with 100. And then you have another rest, free space, another 29 maybe, yeah. So this is on data level, while for code levels, you're going to know, okay, under target, you're going to do several things, and then you're going to jump back to the target whenever you call it back. Okay, this is still under instruction, okay, because you have label, instruction, mnemonic, operand, or command. So these data labels, these code labels are under instruction. So you instruct, you give instruction. And second is a instruction mnemonic. This is the things that I mentioned just now. Move, add, sub, mouse, JMP, call. So all of this is short form if you notice. Move, MOV, is a move, assign the value to another. Add, it means as addition, you add two variables. Sub means that subtraction operation, which is one value to another, you're going to subtract. And multiplication for MUL, you're going to multiply two value. And jump, JUMP, which is you're going to go to a new location, jump directly to the certain place that you're going to call. And lastly, call for procedure. Whatever procedure that you have, you call it back. So that is under a second thing in your instruction. Just now you already look into label, data label, and also your code label. And after that, you look into your instruction mnemonic. There is still another things, basic under assembly language. I hope that you can stay tuned. Okay, there is a operands. So assembly language instruction can have between 0 and 3 operands. So normally maximum we can have in one single line between 0, which is 0 means tak ada. You tak ada pun operand that mentions. That's why you can see here operand is usually required, but sometimes also it is optional for you. So that's why it can be 0 or a 3 operand. What is means 0? 0 is not put 0, okay? Means that tak ada. There is not non-operand that you write in your single instruction or single programming. So the maximum you can have the 3 operand in one single instruction. Following table contains several example. Okay, you can see here what is operand basically. So operand can be a constant, which is the value of your number. It can be also constant expression, which is there is addition, multiplication, subtraction. This is expression of your constant. You tambah dekat sini, you adding. So that is in term of expression constant. It can be also register, and lastly a memory, which is your data level. Just now you learn on count, which is a data level. So this is example. You can see here example of your single commands here. You only have STC. STC mean set carry flag. So you just have this. And this one means all this is your command. Comment. So you can write a comment. You can also make it blank. So after this semicolon, it is a comment. So it is hard for a programmer to understand what you mention here. So there is no operand. You can see here there is nothing after your instruction. And second line here, there is one operand. What is your operand here? You can see operand here can be registered. That's why you can see INCEAX, which is you include the EAX value. You can see one operand, which is your register, and you're going to add one or increase. I also already forget. INC is what? Increase one. Going to add one to your EAX register. The third one, you can see here, the third single instruction, you have move. You instruct this EBX value and move inside your count. This is your source, this is your destination. So it is slightly different. You can see in this line, you can see normally kalau kita tulis nama ayat biasa, kita akan dari sini ke sana. Betul tak? We're going to write from here to there. But in your programming, it will be first your destination and then your source. Dari sini ke sana. Macam tu. So from source to destination, you write your destination first and then baru source you. So in like your sentences, normal sentences, you're going to write like, I'm going to go to New York from Malaysia. So you're going to move. I'm going to move to New York. I give like this NY first. This is my New York. I'm going to move to New York from Malaysia. So this is how you're going to read your coding or your assembly language. It will mention the destination first, after that the source. Okay, so it is not like a normal things like normally you said, mestilah you kena tulis dulu source baru destination, but it's vice versa in your assembly language. You're going to write destination first, baru you letak source. Move kan, you're going to move to your count from your EBX. Then you can see count is your data level. See? Count is your data level. Then you have one operand. EBX your register. EBX is your register. So you got here two operand. One operand, two operand. Two operand, which is you're going to move your EBX to count. So that is example. you can write in terms of your instruction. And lastly, you can see here about a comment just now I already shared you, which is it is important for a writer or a programmer on to write a program to tell and describe about a program or coding that you are written. And it also too easy a person to read your coding. So typical comment which is a description on the program purpose. Sometimes you akan nampak dekat atas sekali every single sebelum you punya coding, normally going to see the name of the person. Sometimes also you nak letak date. You edit the programming mungkin semalam. So you said, okay lah, another 2 days or 3 days, you're going to edit again your coding. So that's why you will know, okay, bila last date yang you revise that coding. So it is sometime you're going to put into a comment. And lastly, the technical notes. Normally, you put like this, technical note, okay, what you're going to achieve into your code. That is on your comment. And there is several way. There is several way how you're going to write your comment. You can write it in terms of single line, line by line, the things that you see here. Every line there is a comment. So single line, you can write a comment by using the semicolon. You can see after your semicolon, it will be a comment. After your semicolon, it will be your comment. So this is how you're going to write a comment using a single line. Second, you can see here block or multi-line. You nak letak sekali banyak. Sometimes you tak cukup pun satu line tu, you tak cukup a single line, tak cukup lah, panjang sangat. That is too long for you to put a comment. So that's why you can have a block or multi-line comment. You nak type panjang-panjang. So how? In terms of that long comment, how you going to represent it? By using type comment. And then there is apa ni tanda seru ah? Directive character, comment directive and any program chosen character. So you're going to put like this, and all between this you're going to have as a comment. So this is how you're going to represent your comment in terms of long and multi-line, while you're going to use a single line like this representation. So that is the thing on basic. Before you can move to your assembly language, you need to know the very basic thing. Apa yang akan ada, what is the things that will be used in your assembly language. So all of these are the very basic elements. So you just cover until comment first. After this, you're going to know and take a look into register. Just now you look several example on register. You have EAX here, EAX, EBX, AX, AH. So what is basically this or register? EAX, how many space? Sometimes you are given only like this, okay. You can see over here also sometimes you are given like this. But you can also have example, okay, like this, which is you already know how many space you have. But instead, kalau you ada macam ni, which is move EAX my var, which is the one, how many bits that you have for this register. So how you going to put the value into the header kat dalam you punya database you're storing, macam mana you going to put? So you need to know EAX ni 16 bits, EA
AX is 8 bit, lagi apa, AH 8 bit. So all of that, the value and also space, you need to understand. Apa maksud EAX? Apa maksud EBX? A represent as what? B represent of what? ECX. C refer to what? What else? Refer to what? AL refer to what? Then you're going to know that you need to know about register here, which is the basic element yang you selalu guna dalam your punya assembly language. So let's move first to your register. Okay, now you need to know about register. Why you need register? Register are high speed storage. Register adalah tempat you nak simpan. So it's not like called register. Dia tak akan call as a hard drive, hard disk. Hard disk, you store data dalam hard disk. But before you store into like slow speed storage and a big stage storage, you will firstly put your data into register and directly inside your CPU. It is designed to be as you said as higher speed. Later on, I guess in your module 1 you already not in module 1. I guess after this you're going to also see the pyramid things. Last time in your module 1, I guess there is a pyramid also, but it is not on the speed, it is not on the price things. Later you will meet that pyramid thing. You will learn how about the storage side, about the speed, and about the cost. So one of that on the storage is called as register. So it is much higher speed and then your conventional memory that you have in your computer. So it's going to be designed to access at much higher speed than conventional memory. So here are the things that I just mentioned. You got AH, you got AL, you got AX, you got EAX. So EAX is 32 bits, AX is 16 bits, and AH is 88. So that is the first thing that you need to know. Berapa besar space yang mereka ada. How big space that all the register have. So in term of over here is all A. Later we know that what is A, but it also can be B. It can be also B, and etc. So we will look into what all the meanings. But first thing first, you need to know about their space. If AH, then you know it is 8 bit. Okay, example I give you. Move AH, and then I got here 17H. H is my hexadecimal value and I want to put into my register. My register AH. AH is 8 bit. So I know that it will be 8. 1, 2, 3, 4, 5, 6, 7. All together is 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is the space. And I'm going to put my 1, 7 here and the rest will be 0, 0, 0, 0. Next is I have another move AL. Let's say So it's going to be move to another space. Lepas ni kita akan nampak the hierarchy of this table, but you need to know it occupies it. If it is 16, then you will move to another 16. So it will start to another space there. So that's why you need to remember berapa besar the space that it have for each register. So in term of bits, if you convert a 16 bit, you're going to get 1 byte. If you have oh sorry, I guess this one is 2 bytes. 1 byte, 1 byte. And 16 bits equal to 1 words. And 32 bits equal to double word. So this is the thing also I already mentioned. It's very important for you to remember bit nibbles by words. After that, if there is double words, double byte, then you know it's how big they got the space, right? So this is the similar thing you can apply for EAX, for EBX, for ECX, for EDX. Similar space, you can see over here we have 16 bits for AX, BX, CX. And after that, we also have, okay, for B. For B, you can see here, this is all B. B is called as base. Base. C is called as account. D is data. In A, I forgot the name of A. Accumulator. A is accumulator. B is your base. C is your count. D is your data. So all of this is a register. And you can see, okay, before we go for next, we're going to stop now. Any question? Any question on the basic element for your assembly?
Tak ada question doktor, kompleks sikit je. Kena go through lagi sekali.
You kena, kadang-kadang you already like understand. But in term of apply, bila nak pakai tu, nak guna pakai tu, dekat situ is going to be
Krik-krik sikit.
quite confused because kalau you dah biasa, then it's easier for you. But example like this, operand, okay, you know, you boleh baca dan you boleh hafal every single things. But when you want to apply, that is the thing for you to know, right? That's why
Ya doktor.
kena banyak exercise.
Okay. Okay doktor.
Ada question ni? Kena buat dulu baru tu. Yes. So you kenalah lepas ni guna Visual Studio banyak kali untuk membiasakan diri you dengan assembly language. Kita move lagi dulu.
Doktor, test esok pagi doktor.
Pagi tu I rancang kita discuss lagi because saya risau, to be honest, apa ni, UTM perdana kata lecturer tu macam susah student nak score. So I risau. That's why after this,
Yes, doktor.
Ya doktor.
after
I tengok
this,
slide tu pun saya dah takut dah.
Yeah, very
Modul
worried.
2 tu.
okay, you tengok dekat sini, I dah upload dah you punya mock. So
Okay.
lepas ni kita akan ada break. So you try, waktu break tu you try about 40 minutes for mock part A. Tapi mock ni saya dah reducekan soalan. Kalau you punya test
Test.
1, it is supposedly 40 minutes. Like macam contohnya 5 soalan, tapi saya dah reducekan 3 saja. Macam tu. So saya
Okay.
nak tengok sama ada after I dah reducekan, you dapat jawab ke tak? Faham tak?
Okay, doktor.
Okay. Nanti Part B pun ada juga mock test. So kita tengok and then kita discuss together.
Doctor,
Yeah?
in the video you mentioned that the model 40-bit model for floating point not cover in the test, right?
Huh?
Yeah, in the video you mentioned that not cover in the test.
I think I said it's cover because it's supposedly cover from module 1 until module 2.
So everything cover, is it?
Yeah, supposedly.
Okay, okay.
Okay.
Tak tidur malam lah nampaknya.
Tak apa, but because part 2 if you submit it dalam kertas kan, you submit sekurang-kurangnya I can marking and then I can tolong. Kalau directly daripada e-learning, itulah jawapan you, itulah markah you, I cannot like change, right? So
So kita kena submit macam mana, doktor? Kena submit dalam kertas ke, doktor? Untuk part 1,
okay,
part 2.
kalau part 2 ni, kejap saya tunjuk dulu. Dah habis lah. Okay, ini yang UTM punya student, kita panggil perdana. Okay, student perdana akan buat macam ni, which is they directly jawab dari sini, dalam ni. So dalam e-learning. Tapi kalau you tahu kadang-kadang pun how to answer, sometimes it can sit over here kan, round the fraction to decimal digit. Kalau you tersalah pun, contohnya 1 0 1 1 1, you terlebih 1 digit lah contohnya kan. Tapi jawapan ni betul ni betul kan, jawapan depan ni betul. Tapi sebab salah ni, machine akan jawab, okay ni salah semua. So you akan dapat kosong.
Oh, ni kalau tak space pun ni salah ni. Kan, doktor?
Betul. Kalau tak space pun salah. Kalau you letak macam ni, space pun salah. So that's why maybe you I will give you the similar things macam ni kan, the view tu macam ni, tapi you tulis balik dalam kertas you punya answer. Nanti saya akan marking.
Okay, doktor.
You submit dekat e-learning.
Besok test 4 soalan je lah, doktor. 3 lah ya.
Maksud dia?
3 soalan je kan, doktor, esok test.
Mana? Mana ada 3?
Oh, okay.
Maksud 3 tu macam mana? Kita akan
No,
ada.
he asking for part B, doctor.
Oh, part B. Part B 3 or 4? I forgot already.
Okay.
3 or 4.
Part A?
Part A 30 ke 40 soalan?
Objektif
30,
ke subjektif?
Objektif.
Objektif kan? Okay.
The subjective for part B only.
Oh, okay.
Okay. So this is like overview. Nanti you akan try jawab. I bagi you masa macam waktu untuk real test. Tapi saya dah buang dah soalan-soalan. Saya buang sikit lah. Saya just nak tengok sama ada you boleh jawab tak. Kalau saya buang soalan sikit, dalam masa yang diberi, you dapat jawab ke tak. Macam tu. So saya dah letak dekat e-learning, dua-dua e-learning saya dah letak cuma saya hanya unhide untuk part A dulu.
Okay, doktor.
Okay. So kita continue dulu untuk modul 3. Lepas ni kita break. So waktu break tu you buat you try buat untuk soalan part A dulu. Lepas tu kita meet lagi, kita bincang part A macam mana. Sebab question tu dia akan random. Contoh part A ni you akan random dapat. Mungkin soalan pertama you dengan soalan kawan you tak sama. Dia memang macam tu. Dia akan random. Semua soalan random.
So buat test esok pagi doktor? Sunday pagi
Sunday. Mungkin kita mula dalam pukul 10 atau 11. Pagi tu kita jumpa dulu. Pukul
Okay.
8. Pukul 8 kita jumpa dulu. Kita discuss apa-apa. Kalau ada soalan lagi, tiba-tiba malam ni belajar kan. Banyak lagi soalan. So kita discuss
Malam ni
dulu.
tak tidur lah.
Dan kalau rasa macam okay, ready, then kita start. Okay.
Okay, Atta.
Okay. Kita mula lagi. Kita sambung kita punya module 3 first. Okay, so that is the things and the basic elements for our assembly language. We move to 3.3, adding and subtracting integer. So this one, kita dah tengok dah. Kalau you still remember, kita dah tengok dah program template ni. Masa kita cuba untuk try to play around with our Visual Studio, kita dah tengok template.asm. Alamak, siapa yang pergi bilik air tu? Okay, you can see that we already look into program template. We already provide you with the template.asm. So this is how basically look like. Dekat atas ni semua, if you still you remember, last time this program template they have like this. If you want to start with scratch, kalau you nak buat dari scratch pun, you tak nak letak ni pun tak apa. This is example. But in terms of the template, you're going to see this part, all of this is a command. Based on what we have learned just now, this is a command in terms of single line. Okay. So this is all the command, the things that maybe you say, okay, the programming, this program is for adding 3 numbers maybe. So you type lah dekat sini just for you to know later on. And then siapa dia punya author? Who is the author? Creation day. Maybe you baru buat sampai sini and then you nak berhenti dulu. You letaklah pukul berapa, waktu apa semua dekat sini. Then bila you nak continue, you say, okay, this is the latest thing I think that I already saved. And revision ke berapa? Maybe you letak version 1, version 2, version 3, you dah updated it, right? And that is the things that under comments you can see. After that, you have also the include. This one is the thing last time. Kalau kita tak ada Irvin 32 ni, nanti kita punya tak boleh run lah, apa lah, ingat tak lagi? So if you still remember, this is the thing that library yang paling kita gunakan, paling important in our COA. And there is data, the things that we're going to play around into our programming after this, and the codes here. So this is just a basic template. Lepas ni you akan edit here, and you're going to put all the thing instruction, you put the variables, you put additional procedure. So where you going to edit? Sometimes you don't know, in dot code ni you nak letak apa. So over here you know, okay, this is for instruction. Dot data ni nak letak apa. What you going to put inside your dot data. So you know, okay, this is for insert the variables. And then over here, after your main procedure there. So what you going to put before your end of your program? So you're going to put any procedure that you have add in addition. So this is a template for you to use. Kalau you tak ada kat atas ni pun boleh, as long as you have the other things in the library, data, code here, and then of course you're going to close your programming with end main. Example under program 3.1. Write the following program in text or notepad and save as. Okay, you can try to write this and then save using this name. And then you can also try to run in your Visual Studio. But of course there is nothing happen because there is no instruction. There is no instruction, but there is no error. You can write it, but there is no output. And then, oh, but here you can see, if you have dumb register, you're going to display the register. Okay, after you have the template, you will play around with inside thing. Of course, your instruction. So in this subtopic, you're going to learn on adding and subtracting integer. You akan buat tambah tolak nombor. That's why numbers is important for you to know, because sometimes in your coding, you're not going to use only decimal. Normally you going to play around with hexadecimal. That's why dalam kita punya extra class last time, I said hexadecimal is important. You kena tahu hexadecimal, because if you didn't know about hexadecimal, you tak boleh faham pun. Ini bukan, this is not 10,000. This is not 40,000. Instead, it is 1000H hexadecimal. So if let's say here you were given with this code, you either move, you're going to move this value into your EAX. So your EAX now, your EAX, it will be inside your storage under your EAX. It will be 10000 hexadecimal. Later we will try to put inside the like header. Okay, this is the first thing when you execute this line. Second, you will inform 8. You're going to adding this value into your EAX. Jadi, sekarang you already have EAX with this. You're going to add another 40000 hexadecimal. Now your value will be 50. Then it's sub, which is going to subtract your value here. Now it's already 50000, right? You're going to sub with 20000. You're going to sub. Then you have 5000 sub with 2000. Then it's called as call dumb register. Kalau you tak buat ini, maksudnya you hanya simpan nombor akhir tadi, you simpan 3000 kan. Bila you dah execute adding, you dah tambah dengan 4000 4000, which is 40000H, you dah tambah, you akan dapat 5000. And then it store, dia akan simpan it's going to store back to your EAX. And then after that, you akan tolak pula, which is you sub with your 20000. Last you mesti akan dapat you punya EAX equal to 30000. Tapi bila you execute ni and then you exit terus, bila you exit, which is you exit, it not going to display. Dia simpan saja, means that if you going to store only. But if you want to display, you nak tengok jawapan akhir tu, you need to use this one, call dumb register. This call dumb register is for you to display the register value yang paling akhir after you execute all the code here. So then you barulah you nampak bila you execute and then you dah habis run semua, then you akan nampak after you debug, you akan nampak EAX equal to 30000. So please try like copy this and then run into your Visual Studio. You akan nampak beza dia. You letak call dumb register dan satu lagi you tak letak call dump register. What is the difference? And here you can see, okay, and I already mentioned also starting. You can see starting, normally kalau you execute step by step, kalau you execute terus, you takkan nampak all this value. But when you step by step, F10, right, F10, when you press F10, which is execute step by step, you're going to see after you execute this, after this line, when you point here, you're going to see the initial value dalam you punya EAX storage. My EAX initial value sometimes is not similar to your EAX because it's depend on your computer. Kadang-kadang you punya computer is already stored with many other things yang kita tak tahu because you already like execute whatever things that it is using your EAX register. So for first, it's not supposedly to be similar. Nanti you cakap, Doktor kenapa bila execute first ni, first line kat sini dia point here, my EAX ni tak dapat sama. It is because of, it's depend on your register at that time. Ini adalah initial value. But if dalam soalan, okay, dalam soalan, ini the thing that I cakap secara apa, technically it is going to be different. But in question, we going to put starting point. Kita akan letakkan starting point dia berapa. Starting point dia berapa for your EAX. Then you're going to see, okay, after that, it move to here. You go, mana dia pergi? Okay, after that, you're going to see it move to here, then it's going to store into your EAX. Then after that, you add. After you add, you execute this line, you're going to see your answer will be here. Then you step again F10. You're going to sub with your 2000H. Then your answer will be this. This is on your storage. You tak akan nampak dekat dalam display. But when you want to display, you need to use the call dump to display. So last kali kalau you call dump register over here, then baru you nampak you punya output. EAX apa-apa semua. But again, yang lain-lain ni, the value sometimes going to be different due to your own computer, okay? So, but the thing after you execute this coding, you're going to get the similar value for your EAX because we just play around with our EAX. So there is another example lagi, which is over here, basically similar things. Going to add, you're going to multiply it. So please try to do and run into your Visual Studio. Try to play around with different value and try to look what is the answer. And this is the thing that very important because after this, when you given with this, you for this part, you hanya tahu jawapan dia. Okay, what you going to store, what you going to store. And you can see here, kenapa you tak tanya or maybe you not questioning yourself, kenapa there is another like 00 in front? Sebab kan dia dah bagi tahu 10000 only. Kenapa instead of 1000 kita letak 000 in front? Sama juga dengan sini, you tengok the final answer will be also 000. Kenapa dia tak terus tulis? Why didn't just put 3000? So here is the thing when you need to know about dia punya space. Berapa besar space yang dia ada, which is we going to know on the data definitions of byte, word, D word, Q word. Sekarang dah ada QT pun ada juga. and S word. So what is all this mean? So daripada sini you akan belajar Little Indian order untuk you letakkan, storekan dalam you punya data. Okay. Let's take a look this one. Okay. Kita punya normal size. Size paling kecil. The smallest size we ada selalunya kita ada 1 byte. 1 byte ni kalau representkan dia dalam bits, berapa? It's going to be 8 bits. If you still, kenapa tak boleh muncul ni? I dah conteng. Alamak, hai. Kenapa pen ni? So, tak boleh gerak.
Malu tu doktor.
Sekejap hang dah saya punya laptop. This is first time my laptop hang. Tak boleh gerak.
Doktor nak tanya.
Ya?
Terlambat. Yang atas tadi, yang invite 32 tu apa maksud dia? Dia program dalam video serial code ataupun singkatan tu words?
Sorry. Wait Suddenly my laptop restart without my knowing. Okay, I continue back. Just now question about Irvan 32.
Yeah.
It's continue recording, right? Aduh. Can you see my slide?
Yes, doctor.
Okay.
Since
Okay, basically this one is just a library. So you need to have library to point to. Okay. Okay, this is one of library for assembly language, a very basic library. So kita guna this library in our COA subject. You akan ada several other library, whatever library that available for assembly language. But the things that here is we going to use for our COA. Maybe there is a lot of like maybe addition, numbering, and etc. And this normally, I think is very complete library, which is cover, I think, all the needs for programming and the assembly. So you just need to know this is a library for assembly language. If you don't include this library, so I guess you cannot like use like any addition or whatever. You can try to remove, then try to run. Of course it's going to be error because there is no library that you call. So where you going to refer to? Is it okay?
and then okay, and then one more thing just to confirm because include Ivin include code or include Ivin dot include
Code.
is
Where is code?
that one that one just
Fine.
no,
We need to
this
put dot I and C.
INC means include, right?
This one is include.
Okay.
This is the type of file that you call
Oh,
this, yang kita install lah dalam kita punya komputer kan.
I
Uh,
see. I thought I include Ivin include code. Never mind.
okay.
Okay.
So now we continue with the slide. You can see, just now I informed you about byte. If you still remember, byte is equal to 8 bits. So that's why the smallest bit that you have is 8, isn't it? 8, and then you continue with 16, 32, and until 80. So the assembler is not case sensitive. So directive just as a D word, you boleh juga tulis dalam D word small letter. You boleh juga tukar, you can also uh, type. Sometimes there is a capital letter and then in between there is a small letter. It depends because again it is not case sensitive. Then you can see here, this is the thing that we already looked into, but there is new things. I just mentioned there is S, there is D is okay because it's just a double. You can see also there is F. What is F? What is Q? And what is T? Last time when I first learned about assembly, I thought this one is Terra. So here let's take a look what is basically the meaning all of the words here. Okay, byte we know already it is 8 bits, unsigned integer. So B stand for byte. So kalau if let's say you were given with the value, mana tadi contoh dia? Okay, here you can see this is 1, 2. So normally it's going to be like this. This will be byte, 1 byte. Another one will be another byte. So altogether it will be words. Then you need to know how many all of this. Later we kita kira sama-sama, okay? So here a byte will be 8 bits. And then it will be used as a B, capital B. As byte, it will be for sign. You akan includekan sign. where you going to use all these thing? You're going to use in term of mana example. Tak ada example here. Let me try to make example. Let's say you were given with count. Kita guna count lagi. Count. I guna example of S byte. S byte. And then I put the value after that is, let's say, 10H. So 10H, how many space that I have? Kita akan tengok dia, space dia in term of little Indian order. Macam mana kita akan letak, we're going to put into our data storage. And for sign, kat mana kita akan letak the sign? Whether it is a positive, whether it is negative, it is the type of this number. For word, how many? That is the different only, but word semua adalah in term of dia punya how big space they have. Berapa banyak space yang dia ada. And in term of S, it is just a difference between no S, it is sign and unsigned. Sign and unsigned. And double refer to D. D means dia doublekan dengan you punya words. Kalau word, you're going to have 16. For double word, you're going to have 32. S, you include S is only a sign. F is 40 bits, which is far pointer in the protected mode. We rarely use this, okay, because there is too big and banyak pula you nak kena tulis nanti dalam you punya file and etc. in term of your codes. So that's why we normally use D word until byte only. But still you need to know what is F. F is far pointer in protected mode, which is bigger for 40 bits. We have another big things which is Q words. Q words refer for quote. You can see 64 bits. And lastly, T means for 10 bits, 10 byte. So byte, you times lah dengan 10. 8 bits times dengan 10, so you're going to get 80 bits altogether. It is not tera. So now this is the example. Oh, kenapa lah kita tengok depan? Data definition statement. You can see you other example this line. Count the word. So then you know this thing. Kalau dia tak beri any base, it's going to be decimal kan. So for this decimal, you're going to place sebesar the word is 32, isn't it? 32, yes. 32 bits. So there is a space of 32. And then for byte, you ada 63 here. So you're going to occupy in term of your table letter sebanyak 63. But only space dia hanya byte. And double word berapa besar. All of this we're going to learn after this. In term of how you're going to write and put it here. Okay, this is the things that you need to learn on Little Indian Order. Dekat mana you akan letak and so on. So we going to normally start with the offset of 000. Mula kita, address kita akan mulakan daripada 00. Sometime in your question, dia akan beri, they going to inform you what is the starting address. Starting address tu offset kita lah, kita mula dari berapa. Dan kita kena tahu dekat contohnya is ask you, okay, it start with 000. But what is the value at 002? You diberi ini saja. Contoh lah, you were given with double word 1, 2, 3, 4, 5, 6, 7, 8 H. What is the value at address 002? So you need to know the value. Then they said, oh, the value will be 34. Instead, how kena tahu? Then, how we going to put? Okay. Assume our address start with 000. You ada empty storage. You punya storage ni kosong lagi. You ada double word, okay? You going to have 000, 001, 002, and then 003. Every address ni you ada 8 bits. Because apa? 8 bit adalah yang paling kecil. The smallest bit is 8 bits, which is byte, 1 byte. This is 1 byte, this is 1 byte, this is 1 byte, this is 1 byte. Okay, so that is the first thing that you need to know dalam setiap address. Kalau dia beri you mula dengan contohlah 4,531, tak kisahlah, ataupun you ada 14,531. Ini adalah starting address you. So you need to know after that adalah 532, 532, 533, and etc. So it's going to be like that. But the size of this address, 1 is byte. 1 byte, 2 byte, 3 byte, 4 byte, and etc. But that is byte. In terms of bit, it's going to be 8 bit, 8 bit, 8 bit, 8 bit. Okay, that is the things. So, if you were given here, it is double word. Remember, if word equal to 16 bit. Okay, contoh. If example, contoh it is word saja. Can or not? So, word will be 16 bit. This one, two of these will be 1 byte. This will be another 1 byte. This is another 1 byte. This is another 1 byte. So all together 1, 2, 3, 4. You need to have 4 byte if you were given with this number. If you have only words, you cannot store inside your storage because you hanya bagi space. Contoh you ada RM1,000,000. Tapi kalau macam ASB you hanya boleh masuk, the maximum is 200, 200k kan. So that maximum is 200k. So of course lah you tak boleh masukkan dalam that account. So you need, you said okay you cannot, means that error. Because tak cukup size, you tak cukup size. So size yang cukup, you going to give double word. So means that, okay, this is 1 byte, this is 1 byte, this is 1 byte, this is 1 byte. All together is double word. Double word will be 32 bits. 32 bits, how many? Going to have 1, 2, 3, 4. Baru you akan dapat total together adalah 32 bits. Okay, let's say you were given with this. How you going to know Little Indian? Yang hujung ni akan masuk dulu. Yang hujung ni akan masuk dulu. Dan then after that, yang hujung ni yang akan keluar dulu. That is the things under Lithian order. So kalau you nak nampakkan dia in term of macam cawan, okay, dalam cawan. Sebab you akan masukkan air kan. Contoh if you want to pour your water into your glass. So mana yang akan you masuk dulu? You going to put your hujung dulu, which is 78. Oh, masuk dulu keluar kemudian. Okay. And then after that you have 65, 56, and then you have 34. And lastly you have 1, 2. When you want to keluarkan balik, you're going to pour it back. it's going to be this first, and then this first, and then lastly this one. So the first thing that you're going to put in is 78. 78. It start with 000. Tapi kalau macam tadi I tunjuk in term of class, of course lah 00 will be starting at the base. And then 001, 002, and then 003. But little Indian order means the thing at the end over here will be putting first, followed by the rest. So that's why you will put here, put here, put here, put here. In this one byte, you're going to see there is two number, two integer, 4 hexadecimal, okay? You're going to have two integer, one nibble, which is it divided into 4 bit, 4 bit. Another one, this one is 4 bit, 4 bit. This one is 4 bit, 4 bit. And lastly is this one, 4 bit, 4 bit. That's why kalau if you look into your number system, biasanya you akan nampak it's like 1, 1, 1, 1, the maximum number, and then you have like 0, 1, 0, 1. It is 4 bit. 4 bit, 4 bit, 4 bit kan kalau you tulis dalam numbering system. Last time I still remember Divagi asked us in term of our last extra class, Divagi said kalau there is like 8 numbers, normally we're going to separate into 4, 4, 4, 4, right? So that is the thing. 4 bit we combine together here in 1 byte. 4 bit we combine it together into 1 byte. 4 bit we combine it together to be 1 byte. 4 bit. That's why we put here 8, 7, 6, 5, 4, 3, 2, 1. So this is how you going to put into your storage. Kalau ini adalah EAX, address you macam ni lah you going to put. So there will be a question ask you, okay, what is the value at address of 0003? So you're going to say, okay, this is the value at 0003. Kalau you tak tahu, you masukkan ini dulu, then your answer will be wrong. So in terms of Indian order, you're going to pick at the back value, you masukkan dulu. You're going to put it first, followed by the rest until in front. Okay, let's see another example here. You can see, oh, there is a double word. What are the sequence of bytes in hexadecimal in the storage? Dalam storage you, how you going to do? So it have here dalam you punya my data, you're going to have my data, and of course you're going to have storage, which is still empty. It didn't give you the address starting, but you can just assume it to be 000. And for D words here, you can see how you're going to start first. Is it using this first or this? Because both of these are my data. Mana dia? Okay, it's not showing the example. So in terms of the exercise, you're going to start with yang belakang, I said. Then you're going to start with this. So you're going to duplicate, means DUP. This is all the short form that you need to know. You're going to duplicate this one, this value, and then you're going to store on your my data first. Let's say you put this first with this starting 000, and then 0001, 0002, and etc. So you put this, you copy this first, copy this. What else? BC to A. You copy 2 times. Duplicate is 2 times. And then you have another. This one is 1, 2, 3, 4. Okay. Then you got 8 byte altogether. And then you continue. Agak besar juga. You continue with this part on also. You can see here. But there is several things that you need to know. You can see here. It is 25 decimal. If you store into hexadecimal things, you need to convert first. You need to convert this value to be in hexadecimal. Baru you boleh store in hexadecimal. Then you gunalah calculator how to convert to hexadecimal. Kita dah belajar hari tu how to convert to hexadecimal. Then you continue to store your data using your D words. Kalau D word ada 32 bit. 32 bit you ada 4 byte. So you going to pecahkan dia macam ni. But of course it's not this value, okay? It is not going to be this value because of this value is decimal. It didn't put H. So we need to assume it's to be decimal. So you need to convert first to hexadecimal. Later we try to do this exercise together. Similar also, there is another example. You're going to start with this and then followed by this one. This is decimal. You need to change to hexadecimal. This one is character. This one also a symbol, and you have hexadecimal, duplicate, and etc. We will try to look it, and you can try also to run this value in your Visual Studio. What will you get in terms of your storage? Okay, there is also another exercise here, but let's we go through first. Someone want to join, I guess so. I think before we go for higher, maybe we can stop first. Then we will continue after this another about 20 only, 20 plus slide. It is not too much, so we can finish our module 3. But we stop first for a break until 5 p.m. Not a break, not a break. Please go to your e-learning. Please go to your e-learning. There is a mock test 1. So try to do it while like you taking your tea break. You boleh makan-makan, you boleh minum-minum sambil jawab, because supposedly the real test 1 will be 40 minutes, okay? But I already reduced about 12 question. Kalau you tak dapat jawab juga dalam masa 14 minutes, 40 bukan 14, 40 minutes maksudnya nanti dia punya real test you tak sempat lah nak habis. So this is the password. That is the password. Please try to do your mock test. So we meet again at 5 p.m. Is it okay or not? So you ada masa untuk break, nak pergi minum sekejap ke, and then start with your mock test. Okay, ni ada question? Okay
Okay, Doktor.
Okay, nanti kita continue. Kita guna link yang sama.
Okay. Thank
Okay,
you.
at 5 p.m. Okay, bye-bye.
Bye-bye.
Thank you,
Bye,
Doctor.
Doktor.
Okay.